Lesson 108, number 16. It wants us to write this big old logarithm linear, like as it wants us to expand it and have each term be linear. So it says each of whose argument is linear. Okay, so it's expand as the sum of individual logarithms, each of whose argument is linear. That's what might have confused people. Linear meaning that they're not raised to any power but 1. You know, like y equals mx plus b, that's a line, but y equals x squared, that's quadratic, right? We want everything linear, so we want it not raised to a power. Like we don't want it z cubed, we want it just z to the first power. Okay, so start out by, there was a cube root here in the original problem, but I know that a cube root can be written as something raised to the 1/3. So then I went ahead and the cube root was only around the x and the y, so I went ahead and, it's not like I didn't really distribute, but I used that power rule with the logs that I can multiply this to both of the powers. Okay, and then this z, it's to a negative power, so that means it can come up. So that's what happened. I brought the z up because of the negative exponent. I like to use my little timesing dots. 5/3 because 1/3 times 5 is 5/3, and 4/3 because 1/3 times 4 is 4/3. Okay, now I see that I have factors in here. I have 1, 2, I didn't put it, you can't see the timesing dot, it's right there. I have 1, 2, 3, 4 factors. Well, there's a log law that says log base b of m times n is log base b of m plus log base b of n. So basically I can make these as add-ins. Okay, so that's what I'm going to do. Log base 6 of 36, log base 6 of z cubed, log base 6 of x to the 5/3, log base 6 of y to the 4/3. Okay, that's just one of the log laws that we've known for a while. Now, they're supposed to be linear. That's cubic, that's not linear. That's not they're not linear. So just use that exponent law. Well, if I write this, I kind of skipped this step, but if I write 36 as 6 squared, then I have log base 6 of 6 squared. Log base 6 of 6 is 1, and the 2 comes out front, and that's where the 2 came from. This one, the 3 just comes down. 5/3 comes down. 4/3, that's using that, I call it the third log law. It's the property of logarithms that has to do with the exponents. Okay, so I just left it like this, and then I checked it in the answer book, and they have it arranged in alphabetical order, like X, Y, Z. So they just arranged the terms. You might want to arrange yours like this because teacher's aide might not know that we have commutative law of addition or whatever. So there it is.